yours.
Okay, thank you. Right, I can see some of the audience, some of them are pictures, I know. Okay, all right, good morning. All right, good morning, speakers and audience. So let me introduce myself. My name is Shailandra Harahap. I will be the host for the, how do you call it? Teacher sharing session this morning. Okay, so we already have some of the speakers together with us in the sessions, and we will have at 7 up to 8 speakers this morning. Some of them are from the science background and already attend this APCYS since the very beginning, since 2012. So before I go to the first speakers, we already have here Ms. Hani from Parahyangan Catholic University. Okay, so Ibu Hani, can you please welcome all the speakers and all the audience, and before we start the presentations. Okay, Ibu Hani, the floor is yours.
Okay, thank you, Mr. Said. Am I audible? Can you hear my voice? Okay, thank you. Good morning, everybody. Ibu Monica, Pak Yanto, and all the teachers that's already joined this meeting. Good morning. How are you today? Hopefully everyone is in good shape. I am pleased to meet and greet you at this meeting. On behalf of the organizing committee, I welcome you to APCYS 2020. We really appreciate your enthusiasm for joining this conference. Although this year, this conference is online or virtually held. Hopefully this brings new experience for us. Thanks to everybody that makes this event possible. Thanks to the President of APCYS, Ibu Monica Raharti, for all support. May this teacher sharing session run well and be beneficial for all of us. Once again, thanks for joining the session. Enjoy and thank you. Thank you, Mr. Said.
All right. Thank you very much, Ibu Hani. This morning we will start with the first presentations. I will just introduce the first presenter shortly. It's Mr. Tan Kosian, Dr. Tan Kosian from Singapore. Arifin and Risti will help me with the spotlights and technical things. So Arifin, can you help to spotlight Dr. Tan Kosian, our first speakers, and I will read some short CV about Tan Kosian here. Dr. Tan Kosian is a teacher scientist who teaches physics and conduct research at Raffles Institution, Singapore. Passionate about inspiring the next generation of young scientists to solve complex global and community problems. He combines two of his love, research and education, in both the classroom and beyond classroom teaching. His areas of research interests include pattern recognition, machine learning, and computational physics. He has been invited to judge at international research competitions such as ISEF or ISEF, APCYS, APICTA, and APCYS. All right, Dr. Tan Kosian, the floor is yours now.
All right, thanks, Shai. A very good morning to Ms. Henny, Monica, Shai, organizers of APCYS 2020, and friends of APCYS. It is indeed a privilege to be invited to say hello again to old friends and new ones alike. And I will try my best to keep within the 10 minutes today. A little about myself. I am both a researcher as well as a teacher, and that is in itself a very interesting combination, which is very much like how faculties in universities are being run. And the organization that I work at is at Raffles Institution, a school for the gifted children aged 13 to 18 years old. And I'll be sharing my slides right now to give you a bit of an example of what we do at the school. Okay, allow me some time to just bring out my presentation slides. Okay, I'm doing a sharing now. Is everybody able to see my slides? Okay, any issues with my slides? Is everyone able to see? Shy?
For
Everything
me,
okay?
it's quite okay, but
Okay, great.
I can't really
We
see
see
the
you are very
teacher
clearly
scientist
here.
model.
Very
Thank
good.
you.
Good. All right, thanks. Then I shall begin. So the topic for my sharing today is about how we should perhaps also think about following a model that's not knowledge-based of research can also be used in the classroom teaching as a teacher. So my topic today will be about inspiring STEM passion in Singapore using the teacher scientist model. So I come from Raffles Institution. If you look at the top right hand corner of my presentation slide, it is the oldest school in Singapore, and it is devoted to nurturing and developing talent in for children who are gifted aged 13 to 18 years old. And a bit of a context about how Singapore is looking at research. And according to our words from our government, it is R&D is an investment in our own future. And that's why all our students in Singapore will be exposed to some form of research. Now, how we do it, it depends on different schools. And to us, we want to nurture and develop students who are not just able to wash test tubes or push operate machinery, but we want them to be able to create a knowledge-based, innovative economy where they are able to then look at the state-of-the-art equipment or knowledge that can help to serve different communities. So there is a very strong support from our government as a cornerstone of research, innovation, and enterprise. Now, because of this very strong directive from our government, we at Raffles Institution, we actually have created this Raffles Science Institute, where because of the gifted children that we are tasked to inspire, we actually look at how we can merge different research programs that are conducted nationally and bring them downwards to our children who are starting out in their science journey. So what we have tried to model is similar to what the universities have been doing, where a faculty and professor is typically involved in not just doing research, looking at PhD students, training them to do research, but also conducting modules and lessons in the classroom. So what we have done at the Raffles Science Institute is to tap on both national and major research institutions to conduct both research and classroom teaching. Of course, in order to expose our students to the full experience, we actually have a lot of partnerships, both nationally, locally, and internationally as well. So what we try to do with our children is that we have a dedicated team of teachers and specialists who will be able to guide and develop them towards science, technology, engineering, and mathematics by carefully looking at our partners in the area of science and increasingly in areas of non-science for research. Of course, today's discussion is more towards STEM, so I'll leave the non-science research to another day. But I think it's important for us to appreciate that in doing research and bringing research into the classroom, it goes hand in hand, and that's why we are looking at devoted teachers, teachers with backgrounds and experience, and they typically are PhD holders in different areas of research. So if you look at the areas for my team, we do have some of the areas of research. Now we are very careful in hiring our scientists because we want to align our programs to the national agenda. So if you look at the areas for research, there are important national agenda. And this is one thing that I really appreciate about APCYS, because if you look at the different research projects coming from different countries, you will have a good sensing of the national research interests. And in Singapore, what we are looking at, if you look at the some of the 5 topics that are included in this slide, the first topic is in the area of climate action. To us, I mean, Singapore is a island city. We are surrounded by water, and we know that any changes to the environment, to the climate, is going to affect not just Singapore, not just our neighbors, but the whole world as well. And therefore, we have scientists who are working on this area of water and environmental science research. And this year's, because of what happened to many countries around the world because of the COVID-19 incident, we do have areas that we want to build and develop our students in biochemistry as well. Of course, we do have AI, big data, all these kinds of emerging technology. But what I want to share is that every country certainly have their own areas of research. And in Singapore, at RSI specifically, what we are trying to do is to merge a classroom experience by looking at what are some of our research projects that have been done. So what we try to do is, when we look at offering research projects to our students, we do not forget about the classroom teaching. And that's where the science enrichment portion comes. We drive the interest by offering the hands-on. We get them to go beyond the curriculum, the syllabus, outside of the classroom by looking at certain interactive activities to drive all this kind of interest. And these are actually driven at the back end by our work in the research project. So research projects that our students do with us do not just end up with competition. They do not just stop there. We actually continue to use some of these research projects to actually bring them to the classroom to benefit a larger number of students. Due to time constraint, I'll not be able to share more examples, but if you're keen to look at some of these examples, it actually is in the area of, for example, the IYPT, the International Young Physicists Tournament, where most of these research projects allow the students to work on an area, perhaps by creating a prototype, where the seniors can even come to the classroom to share their experiences. They can actually be, more of these prototypes can be built for students to work on this, what we call blended learning, allow the students to look at doing applied learning through some of these research programs. But all this would not have been possible without a strong international program. And this is my last slide. And I do want to, at this point in time, give credit to international collaborations such as APCYS, because I think the students should be able to step out of their comfort zone in a certain country and be able to make friends, be able to see and be able to be exposed to different kinds of activities, research programs around the world. So I do want to, before I end off, take this opportunity once again to thank the APCYS 2020. Am I muted? Okay. So I hope that I have been able to share this with everyone. Thank you for your time, and I hope that you are able to hear what I had to say. So I will unshare now.
Okay.
Were you able to hear me just now?
Yeah. Okay. Thank you very much, Quotient. So I can see that Dr. Quotient is he's wearing the T-shirt from APCYS 2012. It's the first one, the first APCYS. So yeah, it's a nice. So I think he shared like most of his experience combined with how the students in Singapore engage with most of the researchers, and that's how they come to this APCYS together, and researchers and teachers, and doing very well this couple of years. Okay, all right. Thank you very much, Dr. Tan Kosians. And for teachers and audience, if you have any questions, please write and hold back your questions, because we will go to the next presenters, and we will have the question and answer session later. So I will introduce our second speakers. They come from Guam. It's Miss Arlene Chua and Miss Kristen McCormick. A short CV about Miss Arlene Chua and Miss Kristen McCormick. Arlene has been educating students of all ages from elementary to the collegiate level in mathematics and science for over 30 years. She is currently the head of science department in St. John's School. She has been recognized with awards such as Who's Who Among America's Teachers, among others, but what counts in the most in her heart is the love and accolade from her students. She holds a Bachelor of Science in Physics from the Ateneo de Manila University in the Philippines, and master's degree from the University of Guam. Arlene is also an accomplished choir singer and former soprano. Wow, nice. In internationally awarded of Ateneo College Glee Club. When she is not busy with her science students in school, Arlene enjoys singing and teaching music. She is currently the musical director of the St. John's School's Glee Club and the same semi-professional Guam Community Choir Magis and the Nuestra Señora de las Aguas Catholic Church Choir. Oh, impressive. And Arlene will present together with Ms. Kristen McCormick. Kristen McCormick grew up playing school with her dolls and frolicking in the woods. Of course, every year she found herself with the worst case of poison ivy rashes, but that did not stop her adventurous spirit. She went on to earn her bachelor's degree in physiology and neurobiology from the University of the Connecticut in the US. She then worked in the field of genetic engineering and deculp genetics. Remembering her lifelong dream to teach, she returned to schools for her education certifications and then a master's degree in science education. She loves waking up each morning to be with her students, sharing stories and life's lessons with them. She currently longs to return into the in-person classroom. We all do, but is trying to make the most of this time by scouring the internet for ideas and embracing the new adventure. If she has any free time, she still loves to frolic in the woods and scuba dive in the ocean with her 2 children. Nice. All right, Arlene and Christine, the floor is yours now.
Okay, thank you, Sai. I'm going to share my screen now. Okay. I'm going to time myself so I don't go over time. Okay. All right, thank you. So we'll start. Good afternoon, fellow teachers, fellow science teachers. I'm Arlene Chua, and together with my colleague Christine, we're going to present STEM at St. John's School during the time of COVID. So in case you're wondering where Guam is, we're right in the middle of the Pacific Ocean. We are a very small island. with an equally small population. So our school is also equally small. Our average enrollment is around 500, and we serviced students from the very young, the 3-year-old, to the oldest is 16 years old or 17 years old. So doing some math, you know that the teacher-student ratio is 1:9. So this small student ratio enables us to target problems and issues wherever they may arise, as opposed to having, if we had a classroom of 50 students, for example. So as science teachers, we know how important hands-on learning is to science. That's why we do lab experiments. But during this time of COVID, how do we make labs relevant to the students? As a backgrounder, Guam has been under lockdown since March, and we may very well not be able to do in-person learning until the end of the year. So for these 7, 8, 9, 10 months, we will be in distance learning. So how do you make labs relevant in the time of COVID? And so here we present to you some projects we had our students do while they're at home, and we are on the other side of the screen. And we hope that our sharing this with you will enable us to realize the importance of letting our students not just sit passively behind the computer screen, but do something as well. So in the interest of time, I'm going to start with 6th grade. Our 6th graders are 11-year-olds. They learn earth science. And so their labs could be as simple as, how does distance affect brightness? So you just need a couple of flashlights. And you know, it's qualitative, yes. There's not very much measurements taking place. But for an 11-year-old, this already pops in some seeds of learning when they know that the brightness is affected by distance. Here's another experiment that they did at home. They just did parallax measurement. And it's very important to know that this has parental involvement. And so isn't that better if we could involve parents in the learning of the children? If the student is very good in art, for example, so now we have STEAM instead of just STEM, then they can just provide a artistic model of, for example, this earth science teacher providing a model of each lunar face. And if they're not good in drawing, well, they can just find different shapes around their house, like a half-eaten, I don't know, I guess that's a donut or a peanut, to represent waxing crescent or waning crescent. And this is my favorite. The student says, I thought this was cool. I shaped my burger into a crescent moon, or at least I tried to shape it as a crescent moon. The 7th graders are 12-year-olds. They learn lab science, but of course we cannot do this frog dissection and earthworm dissection anymore because we cannot go to the labs. We're forbidden. And so this teacher said, well, let's pick on the creativity of the kids. Let's have them do cell model projects. And in particular, this teacher loved this project of one of the students because she made a pizza. And so she can eat their project afterwards and provide nourishment for their family. They can also do osmosis experiments just using everyday kitchen ingredients such as carrots and water and salt. Our 8th graders learn physical science. And so they can graph a motion of, for example, their cat running across the field with equally spaced intervals. And you know, it's easy to graph them. A 13-year-old should know how to graph. They can build catapults. They can learn about surface tension with just a coin and some water and a medicine dropper. And on to the 9th and 10th graders. And our 9th and 10th graders study a mix of biology, chemistry, and physics. And our 11th graders study a more specialized field of science. So we offer a mix of advanced placement subjects and international baccalaureate courses. And so last week, my physics class, I was just teaching them kinematics and projectile motion. And I asked them, what if your favorite sports is played on the moon? What changes would you recommend? So one group says, what if we played basketball on the moon? What would happen is the following. So they said, the court would be bigger. The dimensions would be multiplied by 6. The basketball hoop will be taller. And one group said, what if golfing was done on the moon? What would happen? And they would say, well, there wouldn't be any dimples with there because the dimples are there for aerodynamics. The techniques that golfers use to adjust for the wind, you can omit that. You would have, because you would be, the balls would be hit much farther, their courses would be significantly longer, the balls would be need to be colored a different color so you can distinguish that from the lunar surface, and so on and so forth. Another project that we did last year during the lockdown was I had them analyze movies with bad physics. And this they particularly like because, for example, this kid did a sci-fi movie, Ant-Man, and says, Ant-Man should be impossible. Why? Because, well, if Ant-Man was based on PIM particles, and according to the movie, PIM particles are particles that just shrink or increase the distance between atoms. And so, therefore, the density would increase because the volume decreases, for example, if it shrinks. And so then the scenes that involve the Ant-Man being carried by an ant should be impossible, or this scene where the Ant-Man was on top of the bathtub should crack under the pressure of his full weight on his feet, on his tiny little feet, because of the incredible pressure. And yeah, this ant should not be able to carry the Ant-Man, and as well, an ant cannot be expanded into a giant size because then the density of that ant is lighter than air, which means that ant should be floating around. Another example of one of my students' work is they did a physics of the dodgeball. So there's a scene, I'm not going to show you the scene, but there's a scene where the hero shot the dodgeball against the opponent, and the opponent was flung across the room. And so with a little bit of calculation involving momentum, she was able to calculate that the velocity of the dodgeball was 400 meters per second. And so she said, well, that's almost the speed of a bullet. So the audience should not have been clapping and celebrating, but calling the ambulance, because then the person would not have survived the impact. But if she was going to recalculate it, she said, according to the scene, and she did some calculations using video analysis, the velocity of the dodgeball should have just been 4 meters per second, which means the person should have just moved very, very slightly, 0.02 meters per second. So should not have moved at all, she said. One of the favorites is Mission Impossible. There's a scene where Tom Cruise fell from several stories from a parking lot inside a car, and he was able to walk away with barely a scratch. And so with calculations, the student was able to say, BMW weighs this much, and so on and so forth. The maximum impulsive force upon impact is too high for a human body to take. And they even calculated that the height that they quoted on the scene was incorrect. So we also, my student says the movie should have been retitled Mission Failed instead of Mission Impossible. They can also do home projects like this. These are vehicles for eggs and the goal was to make the egg survive a fall from a certain number of feet or meters. And also we made roller coasters to demonstrate concepts of momentum, energy, kinematics, and so on. And so I hand you over to Christine for the next part.
Christine, you're still muted.
Thank you. Sorry. I'm glad someone's picking up for that. Okay. I just shared with you on the group chat the Wakelet that's going to go with my my presentation and my slides that are here. Arlene, do you want to click them, or should I do?
Okay, I just let me know.
Okay. So basically what I've been doing, I've been scouring the internet for all kinds of activities, and especially if they're free, to be able to try and get the students involved with labs that are home. So some of the ones that I found that were really helpful, and these are actually helpful in lots of areas besides just the life sciences, which is mainly what I teach. So I'm going to kind of look at some of these. Okay, so next. So Jamboard is one that's with the Google Suites. And what I've been finding is this is a great thing to be able to use for the students at home. So normally at school, I would have a skeleton and I would have them, I even have like the skeleton disarticulated. So I would have them putting together the skeleton. I would have the bones out there and they would be doing all this stuff. We can't do this here. So I put an image of a skeleton and they put these little, they're like sticky notes, and we can move them around. So when we're in the Jamboard session, the students can actually help and we can label the skeleton, and then they can also use this as a study tool. Okay, next. And this is also really good for outlining processes. So with this particular situation, we're looking at how the digestive system, how the food goes from the inside of the small intestine into our blood system. So by using these, I can manipulate the Post-it notes to show the kids the process of things going, and I can actually go through it and everybody can watch it. In fact, I can have everybody take on a role and they can all share and take part in this whole process to make it a collaborative effort amongst all of us. Okay. So another thing that I really like is Wakelets. So with Wakelets, I can put together a whole bunch of online things that I might want my students to do, and I can put them into topics, and then I can share the Wakelet with them, or I can just have it in an organized fashion. So when I'm ready to share it, I know exactly where I can go. So this shows what my Wakelet looks like for my IB biology class. So I've got the different topics arranged, and then I have different numbers of and it can be videos, it can be labs, it can be documents, it can be research articles, all that stuff I can put together to make it organized. Okay. And then I have another one for my sports, exercise, and health science class. And again, it's organized for the different units that we have. Okay. And so this is opening up the one on the skeletal unit. So I have some skeletal, I have the anatomy viewer game, I have a bone viewer game, I have a couple videos that are there, and I have a couple other activities that are easily accessible to help the students. Okay. In addition, having the kids do something at home. So making a model of a joint. So they had to research, find stuff around their house, put it together and try and put all the different parts and label it to be able to, have something at home that they can like put it together with. Okay. So HHMI, the Howard Hughes Medical Institute Biointeractive has a lot of great classroom resources. And they have lots of different activities and resources for teachers that you can go on there and put together. Next. So this was one I like to use for my sports class because we have the Olympics coming up, and one of the controversial topics is gender identity and males versus females and testosterone levels and all that kind of stuff. So this is a really good interactive. So when you go on there as a teacher, you can see that there's a whole group of materials available, readily available for the teacher. And then there's various types of interactions. Some of them are videos, some of them are simulations. Some of them are lab activities that can be done, and they even have different levels. So you might have a high school general level, then an advanced level, and a college level. So there's a lot of different ways you can use these resources. Okay, next. Lab Exchange is really great. It's compiling a whole bunch of different resources from a lot of different websites. And so it's trying to get all this stuff kind of together. And looking at this one in the biological science, next. We can see that they have an interactive about the CRISPR gene. They have a video about fluorescent microscopy. There are other interactions, there's simulations. This is just showing just a small little screenshot, but there's also other areas of science that it has it has links to online courses. This is actually Harvard is putting this together. And so it also has links that this stuff is, at least the major instructions are available in a variety of languages. I don't know how much of the material is in other than English, but you can at least change some of the headers into different languages. Okay, next. This is an Indian lab, so I don't know if our Indian people are here. They're probably familiar with this, but it is awesome. It's called OLabs, and they have different activities in physics, chemistry, biology, maths, and English. And next. So if you click on those, it'll bring you to a whole bunch of experiences. And then, so this is an example that has like paper chromatography. And so for this, there's a theory section, there's a procedure, there's an animation. This is showing you the simulator. I can choose different types of plant material. I can choose different types of solvents, and then I can hit run, and it will actually show me the process of the pigments going through the process, going through the chromatography. And then I can answer questions about it. We can talk about it. These are even good in non-COVID times as an introduction to the lab before we do it in person, but it's especially helpful now. Okay, next. PhET, many of you may be familiar with it. Physics, chemistry, math, earth science. It has some biology. It's a little bit better with the others. Okay, next. Next. One of the good ones for bio is the neuron. Being able to simulate how the things go through is great. NetLogo is a good computer program. It also has great simulations that can be used for a variety of resources. Next. And this is one showing mimicry. So there's a lot of different settings the students can use, and then we can let it go for a certain amount of time, and then we can stop it. But they have a whole bunch of different models. So it's really good with models. And this is actually really good with being able to collect data that you can actually collect statistics and stuff like that for, because a lot of our advanced students need to be able to do statistics for their experiments. Okay. And so, like I said, I shared with you the Wakelet on the group chat, and thank you very much from Guahan. Siju Smahasi.
All right. Thank you very much, Arlene and Christine. So impressive presentations. So what I can see from the first and second presentation is they both bring teaching and also learning science beyond the classroom. Impressive. So I think now we have one or two question and answers before we move to the next presenters. So I think Arifin, can you help me to address and spot if do you have any audience or teachers? You can raise hand and we will put you on spotlight for question and answer.
Yes, maybe can I start?
Okay.
I see. I can't find my hand yet. So can I ask Irene?
Yeah,
nice to
sure,
see you again.
Nice to see you, Dr. Tanit.
Yeah, I enjoyed your presentation last year and also this year.
Thank you, Dr. Tanit.
You know, I like that basketball things. You know, it's a good like a real life situation for students to use what they can imagine if they are on the moon and how to set up the basketball games. And I'd like to know who came about that idea, or yourself or your students or your colleague suggest that type of problem.
So we were learning projectile motion in class. And in the book, there are several alternative assessments. I realized that this is probably not the time to give them a 1-hour test, you know, seated on the corner of the room with a calculator. So instead, they offered several alternative assessments, and one of them, and I made them choose, which among these questions would you like to do? And so they came up with, why don't we do this question on favorite sports as it's played on the moon? So.
Thank you.
You're welcome.
All right, thank you, Dr. Tanit. Can we move to the next question? Okay, if anyone wants to ask questions and need some translation, we have a lot of fellows here from many countries, so some of them also can help you to translate your question. Not yet, maybe. Okay, so can we move to the third presenter then? And then we will have a question and answer session later again. So the third presenter is Mr. Anucha Pratuma. Is a physics teacher from Mahidol Wittaya School from Thailand. So Mr. Anucha have a Bachelor in Science in the Faculty of Science in Srinakarinwirat University, Bangkok, Thailand. And also Master in Physics from Faculty of Science in Mahidol University, also in Thailand. And PhD students in Nanoscience and Technology in Sungkyun Kwan University in South Korea. Mr. Anucha Pratuma already attended many science event and program, and some of the last conference he attended is an annual conference of Thai Physics Society, Siam Physics Congress 2019, and also he attended teacher and student exchange between Mahidol Wittaya School and school in Germany, and also attended the Thai Physics Society and also APCYS 2018. All right, Mr. Anucha, the floor is yours now.
Okay, good morning.
Yeah,
The sound is good.
Yeah.
Okay, so, please, okay, so the first I need to introduce myself a little bit. Okay, I'm physics teacher at Mahidol School, and okay, this is the second time for me to like present in this conference, but still nervous. Okay, and okay, I need to introduce my school a little bit because yeah, it's just some introduce. Our school is like a science math school, like a gifted school. We have like each year we can accept 240 students to come to study at our school, and all students they got full scholarship from the government and to study here. But the same with our like a gifted school, we need to and try to prepare the curriculum for some kind of gifted student, and before they get some graduate, they need to like one side projects before they graduate. And also we have so many activities for them, such as like volunteers activities and pioneer and exchange student to partner school. And this is our school. Okay, but today we talk about the some of the topic is like one dimension of the motions, and we have the same problem with Dr. Christine and Dr. Allen from Guam, because I'm a physics teacher, but we need to do like as experiment, but we cannot do because at that time we have the COVID, and we need to like learn online from that time. And okay, so I try to divide my talk in the first the first is like an introduction to some equipment that I use for the study in the one dimension of the motions, and the second is like how to find the motion of the equations of the motions. And okay, the first I need to introduce of the some equipment. We are sorry, now I cannot see my slide. If you, because my computer have some problem, but you can see my slide now. Hello.
Yes.
Okay. Okay. Because but I try to how can I say, because my computer is become too bad, I cannot see my slide. Please can I restart my
timer now?
อาจารย์ทีนี้ผมขอ restart ได้ไหมครับผม
Do you need to restart the screen
Yeah,
sharing?
yeah.
Yeah.
Because I cannot see my slide now because
Okay.
what the problem? Maybe
Fair
1
enough.
minute. Sorry, one minute because.
Actually, I have your presentation slide. Do you want me to share from here?
I think we just wait for a couple minutes if it's working. If it's not, then the committee we can share the same slide. Okay. While waiting, at least now I can see some of the audience face now. Do we still have Anucha here, or is he restarting the slide or the computer?
I'm not sure. From the participant, I don't see his name.
Yeah, I lost him too.
Shai, here we have many teachers from Indonesia. If you can.
Yeah, I see some teachers from Indonesia, from India, from Malaysia too. I can see Sanjay. Okay, so why don't we use this time while we are waiting for Anucha? Oh, I can see someone from Mexico too, Pascal Alanis, and from Nepal. Okay, so why don't we use this time to continue our question and answer session? If someone have questions for Dr. Koshan and also Arlene and Christine, we can use this time to question and answer session. Yeah, I agree with Tanit about your questions, that it's very impressive to imagine how to build the basketball field in the moon. that's a very unique idea, Arlene and Christine. Is there any other questions about the first and second presentation?
Yes, Sulindra, can I say something while we're waiting for Anucha?
Yeah, sure.
Yeah, from Dr. Tan. Yeah, Dr. Tan, Dr. Tan presentation, and he showed nicely using like a scientist in the classroom, right?
Yeah.
And that reminds me with what we try to do here with Dr. Rashen idea at APCYS. It is what we call research-oriented education. That is, try to use research as a base in terms of learning. So during my presentation, I will show more about that. Maybe Dr. Tan can expand a little bit more about activities that he mentioned, please.
Yeah, I agree with you, Tanit. Tan Koshan, can you explain more a bit what is a teacher scientist in your presentation? It's very interesting.
Sure, I'm very happy to share. I'm still a physicist, so what happens is that again, because of the COVID-19 situation, we do have to take a lot of the assessments of online. And what we have done is that based on last year's research work, some of them on 3D printing, we actually look at getting the students to we look at some of the research projects that we have done in the past, one of them on 3D printing, and we take one part of it out to create as a summative assessment for our students. And this example is actually on creating a turbine. So what happens is that we wanted the students to 3D print a design that allows them to look at a real world problem. And this real world problem that I've given to them is part of a performance task. And we have created 4 performance tasks for the students in the whole level of the physics cohort to choose from. One of them in the area of mechanics, one of them in the area of electricity and electromagnetism, one of them in the area of thermodynamics. And what we have tried to do is we have actually gotten the some of the results from prior research projects that we then help the students to scaffold. And for example, one of the tasks, one of the 4 tasks requires them to do a wind turbine generator. And this wind turbine generator helps them to create electricity, where the next task is to look at water quality of perhaps a contaminated water. So what we have done is we get them to investigate parameters that they think is important, parameters like turbidity, parameters like, for example, whether it is conducting enough. And what we want the students to do is therefore to create a 3D print a set of solutions that they think can help them to then measure the water quality by using perhaps electrical means or conductivity tests. And what our teachers and we had to be very careful is that based on prior research, we already know some preliminary data, and that was also released to the students as part of the formulation of the problem. So when we actually get some of the prior research that informs us of what can be done, what cannot be done, we help to scope a certain part, smaller part of the problem to a larger audience. But we need to be very mindful that as, for example, part of the materials that they need to use, for example, 3D printing the prototype, we have to help them to provide some form of preliminary data that was already collected based on past data. Perhaps this is one example that I can share.
Nice. So if I can summarize, you bring the real work problem into the secondary class students, and then work with them and also guide them to work with the problems with the scientific method. That's impressive.
Yeah, I think this is the power of the session, teacher sharing. I guess you have recorded all this, right? That we can learn more in the future. You know, from the 2 presentations already. I think this information and ideas and adaptation will be useful for other teachers also.
Sure. Yeah. Thank you.
From our Indonesian friends who join in large number there, right?
Yeah.
Very good. I'm very impressed with Indonesia, by the way. You are very active.
Yeah,
that's nice.
Credit to Monica, Tanit. So
is Anucha there?
Yeah, I can see Anucha is back. So
okay.
It's joining us now. So Anucha, you can start.
Yes.
Continue your presentations. All right. Okay. Yeah, we can see the slide now.
Okay. Sorry about that, because I don't know, because if I turn on my computer so long that that's some kind of a problem. But okay, so I will continue to. I try to continue my talks. Okay. Because actually I try to introductions of the ticker tab Permafrost. Just actually we know that when we connect to the currents, they will they have sent the tip inside there. They will hit the carbon paper and the paper tab. 1 minute is the 50 times, and we use that kind of thing to. Normally we find the time displacement and average velocity and excellence so on. But today I didn't present about this one. This one is all the physics know about how to do this. But in our case, it's tied to use to experiment to find some equation of the motion of the one directions during COVID-19, because we cannot bring students or to our school, because our school is like all students stay in the school. That's a problem. And okay, in the past, one dimensions of the motion we need to learn or study with the first normally we give some equations of the motion to the student, but they still don't understand some the people why the equation is come from. And another thing that I do that I did is like give them like the graph VTS which is T something like that to find out the equations of the motion. But now we try to keep them do the experiment, and they try to plot graph by themselves, and finally they're finding the equations of the motion by themselves. It's not like try to memorize anymore. Okay, for start, and also that we know we cannot do experiment in the school. We just make like a video clip to student, because we use like a Google Classroom to like a platform to study, and we make some video clip, and also we give them like these pictures and give them to analyze at home, and they need to submit in the class, something like that. I will tell you later. And after that, from this ticker tip tab-tail is they have some dot line, and this one they need to calculate the average velocity and velocity and so on. But for example, if they need to find the acceleration of the motions of the from this experiment, they need to find something like this. Experiment is mean like change the velocity per time, something like that. But this one we didn't do. We didn't give the student do in experiment, but all the physicists know about this. But now we try to give them to like another thing is try to plot the graph between velocity and the time. Okay, so all the students they give like the kind of paper we call the chicken tail, like tap tail, like the small paper, and they need to analyze by themselves, and after that they need to calculate some, not the calculate, like try to plot the graph from this one, but the what is the graph tell us. And after that we didn't give them like equations, but in Excel, right, we can add some equation to the graph. After that we can get the graph like this, and we find the equation like this. Okay, but what is that mean? Because they have the two number, right, 4.7, and another number is 0.2, something like that. But we need to keep like a dimension analysis to find out what is the meaning of this value. And for this one, we need to check by dimension analysis. We find that, oh, this one is like an acceleration, and another one is like a velocity, something like that. But finally, we substitute of the acceleration and velocity to the equation. We can get the equation like this. And after that, we just do a little bit and mathematics, just multiply by 2 and divide by 2, and we get some equation. This one, you see, the last equation is like equations of the motion for this experiment. Before we do we teachings, or we do in the class, we need teachers, most of the teachers give the equation this one to students, but they didn't know why teacher how the equation come from. But we this time we try to keep them to find out by themselves. And another thing is, again, we use the same of the papers, the tab tails, and we need to give them to find out the velocity and time and plot the graph again, and keep them to analyze the graph. And finally, we can get like this. Okay, because y-axis is velocity, right? The x-axis is the time. And now we can find the slope of the graph is equal to acceleration, because we know that acceleration is the change of speed of the time. And finally, we use dimension analysis again. And after that, we go, oh, this one is should be the velocity. Okay, and the y-intercept should be like a velocity 2. And finally, we can get this equation is come out from the experiment. Okay, and actually, equation automation, they have the 4 equations. Okay, but now how another 2 equations come from? We use the graph again, and we know that acceleration is velocity per time, right? And another thing is we can find the displacement of the how can I say, displacement of the objects that they move by use the area and the graph form like this, and after that we do experiment is equal to 0.1244 meter square. But after that we try to find out the displacement from the thicker time dot or the thicker tails, and from t equal to 0.6 to 0.16, because we use the red line in vertical to analyze our data. But finally we got the same, not same, how can I say, it's nearly or exactly are the same, because it's a little bit too different. It's this graph is proof that we can find the equations of the motions by do experiment, or is it correctly to the method is how can I say it? The correct method to how to find the equations of the motions. Finally, we have the 4 equations from this one, and we just change 1 or 2, 3 equations, and after that we can get the 4 equations come out. And this one we have the new method to how to learn the one version of the motions, but do from experiment and not give them like full equation to them, and to try to memorize something that is I think it's not good. Okay, this is all of the our talks, and thank you for your attention. ขอบคุณครับ
Thank you, Anuja. So yeah, it's great presentations. It's like solving some of the most Asian countries' problem, when we usually start from the theoreticals and do the experiments later, but you reverse the order. You do the experiments and let the students to figure out what's the physics phenomena behind it. Great presentations.
Yes.
So we have to hold the question and answer sessions to Anuja, because we have the next presenters. The next presenters will be from India. It will be Mrs. Suryawanshi. Is she here yet? Dr. Suryawanshi.
Hello, everyone.
Oh, okay. Hello. Okay, Dr. Suryawanshi. So we have your video presentations.
Right.
We tested this morning, but it have a problem, like a little bit laggy to the audience. So it's your choice now. If you want to play the video, we can play it for you, or you want to do the live presentation.
That video is playing, sir.
Sorry. You want the committee to play the video? It's also okay.
Yes, sir.
Okay. All right. So we can play the video presentations, and then we will continue with the question and answers. Okay. Thank you.
One thing, sir. I'm very much thankful to organizing committee APCYS 2020, CYS and FGSI Delhi, India. Myself, Dr. Urmila Devi Vinayakrao Suryawanshi. I am from the New College, Kolhapur, Maharashtra, India. I am presenting here my short view on science research and STEAM practices. Please run my video. Thank you so much.
Thank you. All right. Arifin, can you help us to play Dr. Suryawanshi's video? All right. Okay. Thank you. Enjoy the presentation.
Thank you. Myself, Dr. Urmila Devi Vinayakrao Suryanshi. I am from the New College, Kolhapur, Maharashtra, India. I welcome you all in today's teacher session. I am going to present my views on the topic Science Research and STEM Practices at School. Science research is important in school due to its relevance to students' lives and universally applicable problem solving and critical thinking skills it uses and develops. School students are naturally curious, which makes science an ideal subject for them to learn. Research allows students to explore their world and discuss new things. Science activities such as hands-on labs and experiments makes the research well suited to active younger children. Research is an important part of the foundation for education for all children. Yes, many educators believe that science education should begin much earlier. Science research engages them in research science from the start. Why research is important for students? Because it helps them to have a detailed analysis of everything. When we have a proper in-depth analysis of any topic, the result comes out to be fruitful and also knowledge is enhanced. Other benefits of research to the students are mentioned here. That is, they enhances knowledge, clarifies confusion, to learn about methods and issues, understands the published work, learn to create balance between collaborative and individual work, to know how the original study originated, to know the interest, understanding the rationale. And so many benefits are there. Scientific research process. Any kind of educational research requires a few steps of inquiry to provide the solution to any particular research query. First, we have to observe nature, phenomenon, event, or problem and pose the question. Then develop a model or hypothesis which makes a prediction. After investigation, assemble the data and observe the result. All evidences and conclusions must be analyzed properly. Then present our findings. A successful hypothesis becomes a scientific theory. Again, observe the nature and pose the question. The cycle is repeats. Students' orientation. Each school holds a meeting, includes explanation of benefits of completing a science process. Original students' research must be there. Distributing review science day continuum. There is schedule of assignment, submission deadline, activities and events. Then come to the action research. Is the process through which teachers try out to new strategies, new program, new curriculum, new policy, and new plans. Again, there are many practical problems and supervisors for the supervisors and school principals. Teachers leaving class too often or sitting down always. Texting and calling during class hours. Low mean result in subject area assigned. Teachers' cooperation must be there. Teacher performance must be good. School facility improvement must be there. Absenteeism of teachers, submission of lesson plans, impact of new curricular of program, impact of new school policy, educational needs. Like this, there are many problems. Now come to the STEM. Yes, the 4 STEM disciplines are science, technology, engineering, mathematics. Science enables us to develop our interest in and understanding of the living material and physical world and develops the skills of collaboration, research, critical inquiry, and experimentation. Technology covers a range of fields which involve the application of knowledge, skills, and computational thinking to extend human capabilities and to help satisfy human needs and wants, operating at the interface of science and society. Engineering is about the design and creation of products and processes, drawing on scientific method to provide the skills and knowledge to solve real world problems. Mathematics equips with the skills needed to interpret and analyze information, simplify and solve the problem, assess risk, make informed decisions, and further understand the world around us through modeling both abstract and concrete problems. The key difference between STEM and STEAM is that STEM is an educational approach that integrates science, technology, engineering, and mathematics. STEAM is an educational approach that integrates science, technology, engineering, arts, and mathematics. STEM does not focus on other areas such as arts, music, and writing, but STEAM incorporates art. STEAM, in this word, a character A is added, means science, technology, engineering, arts, and maths. STEAM is a solution to the major drawback of STEM. It is an educational approach that interprets science, technology, engineering, arts, and mathematics. It makes use of STEM principles and integrates them in and through the arts. It incorporates creative thinking and applied arts in real situations. Putting the arts in a STEM is, yes, I think we can. However, arts is not only about painting or working in a studio, but it is about discovery and creating novel ways of problem solving. Why STEAM is important? STEAM is important because STEAM is important because it helps teacher incorporate multiple disciplines at the same time and promotes learning experiences that allow children to explore, question, research, discover, and exercise innovative building skills. Not only STEAM save the world, it can save our kids too by making their future bright. STEAM explorers. It all sounds pretty lofty, right? Go save the world with STEAM. But it can start with our family and classroom. Saving the world starts with inspiring kids to ask questions, to think creatively. It does not have to be hard to incorporate STEAM in your world. It's all around you. And here is a great way to get started. At exhibition, we have to present, perform, and share our research work. Here, for becoming a STEAM teacher, we require to complete your bachelor degree or higher, complete a teacher education program, get student experience, pass teaching certificate exam. How do I start program at school? There are four steps. Establishing a budget range, clarify learning places and spaces, identify existing and need, get resources, develop a curriculum. How to make your classroom a STEAM classroom? There are again some steps. Add hands-on project to your students' day to let them be more involved. Include real-world problem-solving activities. Encourage question asking. Let students make decision about the project they are assigned. Yes, here is the planning of STEAM lab and support. Here is the core curriculum. We have to plan for many weeks and we have to go stepwise through all these steps. In first week, we have to go through the fundamentals, then designing, fabricating, prototyping, programming, production, exhibition. In last 2 weeks, we have to go through the assessment. Yes, the future of STEAM education. There is a processing demands for STEAM workers not to mention the number of creative fields utilizing STEM information. As school shift towards more science, technology, engineering, arts, mathematics, focused curriculum, they will be looking for ways to bridge their classes for a holistic learning experience. This is where STEAM take the lead. I'm very much thankful to organizing committee of APCYS 2020 Indonesia Bandung, Center for Young Scientists Indonesia. I again very much thankful to FJSI team India, Chairman Dr. Anuj Sinha, Director Dr. Piyush Madhav, my colleague Dr. S.S. Patil, our college, the new college Kolhapur, India, management and Principal Dr. V.M. Patil. Dhanyawad. Thank you very much. Thank you very much for being with me.
Thank you, Dr. Suryawanshi. Great presentations. Okay, for all the audience and teachers, we still have 3 more presenters. But before we move to the next presenters, I will open the question and answer sessions. It's open not only for the last 2 speakers, but also Dr. Tan Quotians and also Arlene and Christine. You're welcome to ask any question to the speakers. Okay, please go ahead. Do we have any questions from the audience? The first question. No one for the first questions? Okay, since we are most from Asian countries, nobody wants to come for the first question. We move to the second question now. Okay, yes. Open for the second question.
So I take the second question then.
All right.
Yeah, Anusha, I like your motion, and I think COVID-19 has a positive impact in a way. Yes. I believe that's part of your online teaching to students too, right? Because I heard that at MWIT, lots of teachers had to prepare online teaching very quickly. And I think this is a positive impact because all those materials will be available at all times for students to learn and repeat learning from it. Can you say something more about that, please?
Yes, this is new for us to like online teachings. Is so many things is some kind of we need to learn new material, and now we try to have a new projects like for next semester we also students come to our school, but we need still online like on site 70% and 30% is still like online. We have still have the both kind of things for the new semester. I think it's like a positive because we learn more about new things, and I think they have something is like effective and good in online, because some content we don't need students glad together and come together. We need to like do some kind of video, do some kind of experiment to give to them, and they can also like repeat all the time if they need. Yeah.
Thank you.
Thank you for the question.
Thank you.
Thank you.
I actually have a additional comment. Guosian here from Singapore, and I think that the question is a timely question to all of us here as educators, because I noticed that with technology, like for example, APCYS 2020 is recording this teacher sharing session, and I see that even for my school, we have the advantage of doing what could not have been done previously, the sharing of recorded sessions. In the past, APCYS could only be limited to a small group who attend. And even for me, when I invite some of the keynote speakers, what I will do is I will also record some of these lectures shared by professors. Some of them are very creative. They do experiments using Zoom, and I replay it. I replay it during my other lectures. I intend to replay it for my next year's batch. And I see this opportunity, this wonderful opportunity to record and influence, impact a greater audience. And I hope that perhaps today's video can also be made available to more people, if possible. Thank you.
Yeah, sure. Thank you, Dr. Koshan. Because this session is also now streaming live on YouTube, and also I think after this, either Parahyangan Catholic University or Center for Young Scientists will upload this video on YouTube also, so other fellows can also watch this video. Okay, so now we will continue to the next three presenters. We will go straight to the next three presenters, and then after we finish with the presentations, I will open the floor for the question and answer and also discussions. So I will introduce the next presenters. It will be from Thailand, Dr. Tanit Bernim. So I will read the brief summary about Dr. Tanit Bernim. Tanit obtained his high school certificate from Triam Udom Success School in Thailand before obtaining an Australian government scholarship under the Colombo Plan to study for his bachelor's honors and PhD with a major in chemistry and biochemistry at the University of New South Wales in Sydney, Australia. He worked at the Department of Chemistry of Silpakorn University until his retirement. He has been interested in science education and has been supporting Mahidol Witayanusorn School, or MWIT, Princess Chulaborn Science High School, or PCSHS, and Kamnut Vidya Science Academy, or KVIS. Throughout the years, he is currently an advisor to KVIS. Okay, Dr. Tanit, the floor is yours now.
Thank you, Srindra. And please let me upload, share my screen. And thank you. I really enjoyed the teacher sharing since the beginning. And I myself got opportunities to host during the Asia Pacific Conference 2019 at KVIS, and also the International Student Science Fair 2020 at KVIS also. And I think this is really nice. As I mentioned earlier, we learn a lot from each other. And so my topic today, I like to share what is happening at KVIS. And the topic is how we instill in our students 3 skills. And the picture on the left-hand side is a conceptual model promoted by Dr. Rachen Kosalawit, our principal. When he came to KVIS, he can see immediately that when people ask him, what are we doing at KVIS? And he could say that actually it can be summarized in 3 things. That is, we encourage students to have a research skill, English skill, and life skill. And this is a topic I will spend the time talking with you today. And now, let me tell you briefly about KVIS. I think several of you there have been to our school. And our vision is to be a world-leading science high school, to nurture future researchers, inventors, and innovators, to strengthen sustainable national development. And we are quite a small size school because we emphasize our small class size. That is, we have 18 students per class and 4 class per grade level. That is 72 students for grade 10, 72 for 11, and 72 for 12. So altogether at one time, we have 216 students. And now let's concentrate on the main topic of this talk. 3 major skills to be instilled to students during the 3-year study at APCYS. For research skill, like I mentioned briefly during the discussion with our friend from Guam, Irene, that and also from Dr. Tan from Singapore, that we also emphasis on research and for students to see scientific research as a way of learning. So we have done this, and in the detail here, and we have research presented at conferences and a course of students to study doing basic research and to motivate students to publish paper and even to file patent together with the teachers. That is a research-oriented education. And now let's move to the English skill in this part. For the English skill, it goes hand in hand with the 3 skills developed. That is, we enhance English communication skill among students and increasing scientific presentation skills, and of course using English during our study and the conferences. Now let me emphasize a little bit more on the life skill through team learning. See, we have 6 major skills within the life skill itself to develop personality, discipline, responsibility, adaptability, decision-making, leadership, and to be good follower too. That is to develop followership. I think this is important because at APCYS, we aim for students to be good citizens, not only for Thailand, but for the world also. And to be good people as well as to be good academically. And I like to emphasize that now Dr. Ponsan, our Vice Principal on Administration and also the head of dormitories, he is introducing another aspect of life skill. I just talked to him 2 days ago, and I like it very much. That is to have skill in public services activities. So he's quite good in terms of have the method to score the students, give them score, give them certificate, give them encouragement, and also report all these activity of students from the dormitory to parents every week. So every student performance in 6 criteria here will be reported to the parents. So parents help the school in sort of shaping up on those skills also. I think this is quite a good way to do it. Now let's come to the research. For example, international collaboration like we are doing now is very important. I just gave you one example. This is about our satellite educational satellite project. We have visitors from Moscow State University. Dr. Nikolai Videnkin He's here. He came here only for 10 days. Within 10 days, he worked with the student to construct this Yaki antenna to be put on the top of the building, and student will manage and then get the signal from space and from a satellite, and then decode into the map of Thailand. And they learn a lot together. It's a team learning, like Dr. Rajan always mentioned. We have one here from GISDA, one teacher from mathematics, our department, and teacher from computer, our alumni. Some of them now study overseas. This lady studied at Purdue University, our current student, and our past year student. And Dr. Nikolai act as a center, and we have a teacher like facilitator. We also mentioned that teacher role at KVIS are facilitators, that is facilitate learning, because one teacher cannot do everything. That's one thing I like to emphasize about our research skill. And it's an expansion on what we did. For example, on this work, we use computers to track the satellite and see when it's coming close to KVIS. Since the satellite moves very fast, only 90 minutes can complete the circle around the Earth. So every 9 minutes, and then we can detect it's coming, and then we take the signal, and then we get information. And in the future, when you come to KVIS during the next conferences, and we're going to have this observatory and telescope to follow satellites and debris, and also the planetarium for school children around here also, and visitors. And to do that, we managed to have up-to-date state-of-the-art facilities. For example, we have a tabletop scanning electron microscope up to micron level, where students can work on various projects. And here are examples of our research effort. For example, 2018, we have KVIS Invitational Science Fair, because every student here have to do a research project. They can do 2 or 3 or 1, depends on their organization. And at the end, they have to do presentation. And this way, when we have our own conference, we invite our friends from overseas to join. And then 2019, we joined, we the host, and joined Asia Pacific Conference of Young Scientists. And then our students got chances to present their work. And early this year, we also organized the organized the 16th International Student Science Fair. Our students also got opportunity to present their work. Here are examples of research work. Some of them are published in Elsevier, and this is another example of the research work by students and teachers together. And we emphasize on international exchange, that is research collaboration. These are students from Moscow State University, our the school, Advanced Education Science Center of Moscow State University. And of course, this is the teacher, Dr. Alina, Dr. Rajan is Michael's student, and this is another student. And they came 2018. And also we encourage visiting teachers to come to Thailand. This is Dr. Ekaterina Medalieva, who is a distant relative to Dmitry Mendeleev, you know, the father of periodic table. And one time she gave a beautiful lecture about the history of periodic table since her grandfather's time. Very interesting indeed. And this Christian Hawk from Queensland, Queensland Technology School, and she's an outstanding teacher who received award in physics. So to achieve all those, we need international collaboration. And these are the countries that we have signed MOU with, we have exchanged, and we like to have more. I hope some of our friends on this conference would like to join us. You are most welcome, and thank you very much indeed. Thank you, Surendra.
Thank you, Dr. Tanit. What an impressive presentation.
Yes, can I say something more?
Yes, Dr. Rajan, please do.
Okay, thank you, Dr. Tanit. I would like to sum up the whole idea of the KWIS. As you know, our school for gifted, we try to let them learn by themselves, like a team learning, Dr. Tanit said earlier. And also we, if you imagine in the past, when we were students, one topic of science we learn, we might spend time more than the children at these days. They can learn very quick, very fast, as before. Also, what we try to do is we try to open community. The students choose spend time less in the class. They choose spend time more outside the class, even outside the school, even outside the country. That's the whole idea. That what I would like to say more about the KWIS. Thank you.
Thank you, Dr. Rajan. So for audience who haven't met Dr. Tanit already involved with this APCYS even before APCYS established. He attended also the first meeting when we first founded APCYS. So his presentations about the collaborations is also in line with the soul of APCYS. And I also spot Dr. Rajan's photo in one of the slides of the presentation there. Okay, thank you, Dr. Tanit and Dr. Rajan. Very impressive presentations. I have to go to the next presenters. I will introduce the next presenters. Will be from Russia. He organized the previous APCYS, last year APCYS. The next presenter is Dr. Vazili Pavlov from Russia. Is the principal of the Sakha Junior Science Academy of the Republic of Sakha, Yakutia, Russia. He holds bachelor and master's degree with distinctions biophysics from the Moscow State University. He received a PhD from Leeds University in UK. He held various academic positions at the Northeastern Federal University and the Yakut Science Center of the Russian Academy of Sciences. Since year 2000, Dr. Pavlov has focused on the gifted education, set up a top math and physics Olympiad training center. All right, Dr. Vazili Pavlov, the floor is yours now.
Okay, I just can't find my window. Sorry. Okay, that's me. Right. Okay, talking about Yakutia, this is in Eastern Siberia, and I'm actually taking this opportunity, thanking you, the organizer APCYS, for inviting us and our team, and also very much I would like to send greetings to Dr. Rajan and Dr. Tanit for having us, a small group of delegation last year at their very beautiful school in KWIS, which was wonderful. And we are actually working in this very same line of thought as in KWIS, because we trying to develop the so-called community of the similar-minded youngsters who are interested in science and can help and work together in the mode of collaboration. This is Yakutia, which is quite a large region, but with a very small population. It has a very extreme climate. In winter, it gets very cold, down to minus 60 degrees centigrades, and it's very famous for having many paleontological finds, like the mammals, and also the country full of resources, which has been heavily exploited in recent years by the federal government, obviously. And we have enormous and very long rivers, very famous ones, which is, as you can see, one of them is called the Lena River, one of the longest and the biggest rivers in the world. And the entire territory almost of Yakutia is in the permafrost area. The research through amongst the school children was established more than 100 years ago. In this picture, you can see the group of youngsters in 1890s who's been doing some local research, going out into the forest and some other areas, trying to find some interesting minerals and so on. And they have been very much working in the close cooperation with the Russian Imperial Academy of Sciences, which is a very good to start with. And the second thing, this collaboration continued on even after the beginning of this last century, and it was come to the climax in 1920s and 1940s. Many youngsters took part in various expeditions, and it's also continued in the 1950s and 1980s. When there was a very fashionable to start so-called the school fields expeditions, etc. Every school had its own group of youngsters who were interested in studying what in the surrounding area, what sort of reaches it holds, etc. And it continues on, for example, in terms of more specialized expedition that children do during the summer months, sometimes in winter. For example, this expedition, which has been supervised by the Russian Academy of Sciences, which has been going on for the last 25 years. And we very much believe in research as the way of getting some information and knowledge, because people, when they're working together in groups, etc., they can develop far more apprehensions about the science. And the principle that we're using is that the field research is the most important technology that we can use for the developing and the popularizing science. And children, for example, we invite many people from different countries, and kids that working from different countries can develop these collaborative skills when they also accompanied by some professional scientists. So therefore, we develop certain events such as international research schools, which is we carrying out every year, international research expeditions and academic exchanges. Some of the field studies cover interesting projects, such as the development throughout the ages of the, for example, local city of Yakutsk, which is the capital of Yakutia, or there's some natural occurring phenomena like the snow-covered areas that is still in presence during the summer months, and how they've been coping with the climate changes, etc. And then we have a very interesting research on the permafrost. Permafrost is when the entire earth underneath your soil cover is completely frozen and is defrozen down to 1,500 meters and so on. And also during the summer, we have many forest fires because it's the very forested areas, and because in the summer also we have a extreme hot weather, like in up to the plus 35 to 40, 45 sometimes. So it becomes extremely prone to many forest fires, and the children study that using all sorts of material like satellite pictures, etc. And then we have also unique and interesting projects, something to do with the ancient animals like mammoths. We have a collaboration with Mexico when our kids also go to Mexico and study there the findings of mammoths, and it's turned out to be these mammoths in Mexico and the mammoths in Yakutia have many great similarities. In fact, they are of the same species. And also we have quite a few years that we've been developing very good exchanges. For example, this one with the Hong Kong educational institutions, very nice ones, and the top schools from Hong Kong send their kids to study paleontology, permafrost, etc. during the summer months, and they've been enjoying it thoroughly. So the entire activities that we do come to many different interesting events. Some of them is the concerning with the Olympiads, because the Olympiads is the one of the key key events that's how we gauge the entire absolute gifted abilities of the children, and also we very keen on to develop their research skills, because when the children only do the Olympiads, they somehow lose out on the research skills. So this is the most important things for us, somehow to prompt the Olympiad teams members to take some of the research activities too. And this is our Science Academy. We have many foreign students that come during the summer times. This is our main body, which is working under the auspices of that organization, which is called the Serious Educational Center in Sochi, which has been under a very good support from the President of Russia, Mr. Vladimir Putin. And also we working together very in close collaboration with the local university, Federal University, when we set up something called the House of Scientific Collaboration together with that university. And also we are very happy to work with the federal programs, which is supported by the federal budget, something called the Quantorium, which is the Children Research Park, where we're trying to develop some projects together with the currently working scientists and the industry people, etc. So this is the my short presentation on the ecosystem that we have at the moment in Russia, and in particular in Yakutia. The most important thing that I would like to say is that we're trying to develop communities of the research-minded youngsters, that they work in collaboration with each other. Very much similar that Dr. Chain said concerning to the Kiwi School. So thank you very much.
Thank you very much, Dr. Pavlov. I think some of the audience already have some questions about how to engage with some of the school programs in the presentations, and also how to do collaborations with some of the speakers. But we have to hold that questions because we still have one more speakers. So let me introduce our last speakers for today. It's from Taiwan, Professor Fujoming. Professor Fujoming is professor at Physics Department at National Taiwan University. He is also director of Center of Teachers Education, National Taiwan University. He received PhD from Physics Department from Katholieke Universiteit Leuven in Belgium. He has been serviced as a director, Science and Technology Divisions, representative office in Moscow, Taipei Moscow Economic and Cultural Coordination Commission, professor and department chair at Applied Physics Department, National University of Kaohsiung, Taiwan, and professor of Physics Department, National Kaohsiung Normal University, Taiwan. Also visiting scientist at IBM Almaden Research Centers, I think it's in California, and visiting researchers in Tokyo Institute of Technology, Japan. All right, Professor Fujoming, the floor is yours.
Hello, and nice to thanks for the introduction. And I try to switch to my PowerPoint, right? So, how can I do that? Share is already? No? Not yet?
Not yet.
Oh, I got trouble. Just now, I got it.
I think you have to share and select which window you want to share.
Yes. Yes or not?
Nope.
I already share. Okay, I do that. trouble. If I do this way, and I
haven't seen your screen share.
yes, no. So usually it's in the button, right? Share.
You see the screen share button, the green one in the bottom, and then after you click that one, you have to select which window you want to share and click the blue button. Share.
Allow many participants to share, right?
No, not that one. Just don't click the arrow. Just click on the green one.
Just click on the green one, right? Come, I get trouble. Green one. Yes.
Yeah, after you click the green button, you will see the multiple windows in your screen. Like one of the window. The window of your presentation.
And I success or not?
Yep, you have to click the blue button on the right below the button, the share button.
So I
maybe do you have Professor Fujoming presentations?
Yeah, I modify a lot, and sometimes they will make mistake because I use Apple. So I try to share the screen, right? In the green one, right?
Yeah, click the green one, and then the multiple windows will appear.
Multiple window, yes.
Select the window with your presentation.
Yes.
Yeah.
Okay.
There you go.
Yes, we saw it already. That's nice.
Yes, this time, right? Okay. Yeah, great. Okay. So sorry, some technical problem. So I'm going to talk about Taiwan curriculum reform recently. So it's a kind of reform very different from previous years. So we call competency-based education, and certainly it's cover a whole area. But I will talk briefly about the something in the science area we call exploration in science, and certainly recently very hot topic about the content education. So I'm going to share a little bit with you. The world is changing right now. Okay, so you already know me, and certainly as we know from the OECD, the future education, so they have some goal for the future plan for most important is about transformative competency, right? So, and then in this transformative competency, they indicate three most important items. One is creating new value. This creating new value doesn't mean just for the new idea of the knowledge, but also the whole philosophy of what's the education and the knowledge. And then the next one is about reconciling tension and dilemma. It means in the world nowadays, many difficulty and conflict of each other. So this kind of ability or even the tension is must be paid for this area, and also not only to release personal tension but also for the community. And certainly the third one is taking responsibility. So this responsibility is for family, for the society, for the country, and for the world. And certainly this is the goal, the main picture for this. You see, transformative competency is what they emphasize for this area. And previously, certainly, we emphasized about knowledge and about the skill and the value and the attitude. And certainly this will be hybrid and then become a kind of important competency for the learning. And certainly for the OECD, they also pay attention about the developer of industrial, you know that nowadays the industrial technology is different. Now we already have a transition from classical by human power. Nowadays we use a kind of digital power. So this kind of digital power need some skill different from previously. So the top 10 skill at least, the first one is complex problem solving. The second one is critical thinking. The third one is creativity. You see, so nowadays, if you want to do something, you need this kind of skill for that. And as for the education, if you see these two curves, the blue one is the developer of technology, and the yellow one is the developer of education. Usually, we provide education for technology. However, the technology sometimes goes much faster because some technology, they have a kind of evolution. For example, the steam engine, for example, the semiconductor, and so, for example, for the website, web technology. So education sometimes left behind, but we catch up, and then we think about something new, and then provide this for future, education. But however, always have this kind of evolution. So previously, we used a science educator to provide curriculum. For example, this diagram. So that's two kind of approach. We can have a final goal for education. The red one is something that like user expertise. Usually we prepare and then we try to reach the final goal. But nowadays, due to the special kind of evolution of technology goes very fast. It's very different from previous time. So it's like an exponential evolution. So nowadays we have to do it like in the green one. The green one means you use some kind of existing knowledge outside the context, and then you also adapt expertise for education. Then you do something like this way and then reach the final goal. So it means we should do it in a hybrid way. It's not just waiting for the new curriculum. Yeah. And especially, you see, for nowadays we call artificial intelligence, the age of artificial intelligence. Previously, certainly we should have data information, we understand the knowledge, and then we transfer, from expertise. But nowadays, especially for COVID-19, we learn about, how to teach the student to search knowledge from the web. So you see, it's reversely. So in this way, and certainly, nowadays in this kind of cyberspace, we have full of the knowledge. And what's the goal for education? Certainly, we should tell them how to use the knowledge instead of just transfer the knowledge for that. And I'm not going to mention again, this is sustainable development, the goal of this kind of OECD and UNESCO for that. Certainly, the most important, we should make education for students can have so-called self-directed learning, and not only learning in the classroom, but also they can do it, together for that. And certainly, this is the reform of curriculum. It's in Chinese, but they have a kind of a translation. So we call 108 because Chinese year we use 108. This year is 109. So it's a reform start from last year. And we plus 2. And if we translate the year, like in Western year is 2019, it's a Taiwan new curriculum. As mentioned, it's a competency-based education. So their translation is not so good. For example, they emphasize, this kind of spontaneity. This we should say this is a kind of self-motivate instead. This one I prefer self-motivate. and interactive for with their mentor, with their peer, and not only study by themselves and also to learn a common good. So the students are regarded as a self-direct learner, and they should have their motivation and the passion, and certainly they have developed their learning with not only their self but also with the classmate, society, and even the nature for that. So they try to obtain the common good with themselves. So this is the so-called lifelong learning, and they are not only learning from K to 12, but after that they have to develop by themselves. And so in this way, so how to guide them for learning? And certainly learning is not necessarily an outcome of teaching. Yeah, usually the student, yeah, they learn, yeah, mixed with their existing knowledge. So we provide information, and then they try to reorganize by themselves, certainly to provide the question and explanation for them. So it's called inquiry-based instruction for that. So I'm not going to give so many details. This already done by many persons. And certainly in the classroom, so we also emphasize the inquiry and also cooperative discussion for that. This in the classroom, for example, we usually ask some question, and then they can think about, yeah, how the main idea of the class, and then you give some kind of instruction. Certainly they can also prepare some knowledge before entering classroom, and then in the classroom they can make a discussion, and we do something like this. So it's a way of teaching. And for my class, I also teach this kind of gift student. So I'm not going to teach them, yeah, just like a regular way, teach them what's the Newton's law. Instead, I ask them to think about in the very beginning, yeah, what's the philosophy from Aristotle, and then what's the evolution from Galileo, and also, yeah, finally to the Newton. And certainly, I teach them from the beginning of thinking, right? Why the Galileo think about the Principia. He wrote a famous book. So this book is like the book of law. Yeah. So instead of that written in the textbook, it's a natural philosophy. Usually they make a definition, the quantity of matter. So people were surprised. What's the quantity of matter? Yeah, certainly. You see how clever of Newton. He didn't mention about mass or weight, because one object may be changed the weight in different place. He used density times bulk. Bulk means volume. And then second definition is the quantity of motion. So in that time, he tried to understand what's the energy, but he used momentum for that. So this is kind of definition of velocity and the quantity of matter as a definition one. Quantity of matter is what today we call mass. So you see, m times v equals momentum, etc. So, and then he start with a low 1, low 2, low 3, or something like that. Certainly, I'm not going to give a lecture here, yeah, for our discussion. Instead, I teach, yeah, just show you. Certainly, a way for teaching science, yeah, that's a kind of a theoretical way or scientific approach for that. So, yeah, this kind of joke, right? Like in the quantum science, you can catch a line, yeah, just binding them in the quantum wire, or you use a kind of semi kind of membranes, yeah, to catch the line. And certainly, yeah, scientific approach is, yeah, important for learning science. Just back to, yeah, the approach. First, identify the question, and they have to make the search, right? The search many times we call research. Search the idea, search the information, we organize, define, and to design the experimental approach, and then they make analysis, and then they should make a conclusion. This conclusion is not just write a paper. They have to share and make a discussion, just like our activity for that. And there's many way of learning. Certainly, this will be the other lecture, the other lesson for our section for that. So to make a kind of learning in Taiwan, this kind of reform we emphasize for the science curriculum. So previously, yeah, we teach physics, chemistry, mathematics, and biology, but independently. And nowadays, we try to reduce from this kind of curriculum, each part by 1.5 hours, credit hours, and then to make a summation, to make a kind of project we call hands-on and practice. So in this way, so the hybrid, they can make a kind of project in the high school first year or in the second year. And certainly there will be some guideline for this kind of teaching model we call DDMT. D is a kind of discovery. So they should try to work as a several group. They try to maybe provide some material, or by themselves they can identify the problem. So they identify some kind of problem, and then they try to design, yeah, the topic they were going to study. So we call problem definition, and then the solution plan, and then they can try to do it experimentally. So they try to get get some data. They try to arrangement, and then they compare with their existing knowledge or the theory they search from the website, and then we call transfer. Okay, they make a presentation, yeah, to and also report. So this is not only for science school or scientific class. They are doing for whole, yeah, whole school. So we call curriculum design, yeah, curriculum reform for that. And certainly, very important for me, I always emphasize, usually not only for in the class, even in the science exploration. So I usually emphasize scientific approach. So systematicity is very important. For example, like the thermal conductivity. Yeah, usually we want to measure the ability of the thermal conducting, yeah, of material. So probably you will start from some kind of formula, and then you get kind of equipment. However, this is important. First, to think about what's the variable. So you have to think about what's the independent variable and the control variable, and the output, the result for this. So if you make this kind of way of thinking before just use a formula or before study the textbook, so think about what's the variable. So is delta Q versus T important, or something else? You see, dQ dt versus dt dx. This we call thermal gradient. And certainly, if you have this kind of idea, certainly you can try to design your experimental approach, and then you get data. Finally, yeah, you can compare with the formula. Yeah, and this is the kind of approach for that. So this scientific way. So we just start for the two year, and last year in Taiwan, several school also my student who become a teacher already try to do it, and certainly student, yeah, learn, yeah, a kind of attitude from this kind of approach, and then we find difference. So the student, if in the first year they already do some kind of project, in the second year they have different way of learning, because traditionally they teach or learn from the textbook or teach from the blackboard, yeah, and then in because this kind of training, so they could, yeah, think about, okay, the approach, how this kind of series come from, or what was discovered. And the other one for give students in Taiwan recently, yeah, we teach them some very new, yeah, kind of physics. So you know, nowadays we are in the age of, yeah, so-called digitized age. However, there's a big evolution, yeah, for this kind of computation. So now, yeah, for classical bit, we use a semiconductor bit we call 0 and 1. It means in this we use a kind of diode or CMOS. We have charge or no charge. We call bit. So classical one, this kind of a unit. But for the quantum computation, we have different kind of approach. We call quantum bit qubit for that. So I'm going to tell you this is quite new. For quantum computation, is very, very different from previous way. So they have two different idea. Yeah, very important one is superposition. It means the state is existing in the same time. So like a classical one, we only have 1 or 0, 1 or 0. However, in this quantum bit, it exists in the meantime. And also the quantum state exists, and also we call a kind of entanglement is also different from previous classical physics. And certainly, if we back to history, yeah, Jen Thompson find the electron, and also Rutherford find the core of this atom, right? So we call nuclear. Certainly, in classical physics, people struggle very hard, and finally, Max Planck give the idea about this kind of discrete energy we call quantized energy for that. And certainly, yeah, due to those clever person, they find, yeah, this kind of special team we call nowadays quantum physics. Especially like Broglie, he mentioned about the particle like electron or even large particle like a neutron. They are both matter or both wave. How come? If this matter, certainly this is like a bullet, right? The bullet, if they inject for the hole, they should have one distribution, like a Gaussian distribution. However, it's behavior like a wave, so they can have a behavior like a wave diffraction for that. So this kind of behavior is quite different from we call macroscopic physics. In the microscopic world, it's very, very different. And certainly, Schrödinger, they try to solve the equation. Certainly, the basic idea is no different from the skin of Newton's mechanics. So he tried to make a calculation. I'm not going to give a detail to scare you, but you can see the idea, the solution is a kind of wave. However, he give the new idea a kind of probability. This is a confinement of electron in this quantum wave. You can see, yeah, this wave by probability, you see, you can find one particle all in this shape. So probably you learn from the chemistry, you have different shape of idea. You see, this is for electron, yeah, near the core, we call 1s. If this space can have 2 electrons because they have spin up and spin down. Certainly, if you have the third one or fourth one, you have this kind of geometry, and certainly you can have this kind of. So, but each energy of each electron is separate. We call quantized energy for that. Okay, so nowadays, yeah, we have. Sorry, this should be have English, but it shows up Chinese. This is a metal. They have a continuous band, but for individual atom, they have independent band for that. So nowadays, this kind of property is only exists microscopically. It means just a few atoms. And more strange is that for the quantum phenomenon, if that electron, we have a one barrier, the electron can go through the barrier. It's different. So you see, this kind of way, this we call tunneling behavior. And classically, it's impossible. If I try to have a ball, we try to impact to the wall, the ball certainly will not really, go through the wall. So classically, unless the wall was broken by. So nowadays we can have scanning technology microscope for that. So you can have this kind of behavior. And I'm not going to give many typical physics. And nowadays this kind of property was used for quantum computation. So those person give some kind of contribution. You see, it's not too far from Earth. So just within these 10 years, grow very fast. So already this kind of idea already transfer into 0 and 1 state, for calculation, not only by the atomic state, but you can use the photon polarization for that, and also for many kind of possible technology for this one. And just now I mentioned that the state can be called superposition, and even more, they have one special property we call entanglement. The entanglement means, so as long as I can identify one particle, they in 0 state, and the other one, if they even far, for example, far in the Kiwis or in the Russian, they are, so they actually immediately know his state will be 1. We call entanglement for that. So it's very different. So nowadays, if we do not really teach our clever student with this idea, this country, will be really, left behind, from currently. For example, like American, in the Russian, in China, even in the Europe, this kind of technology go very fast. So the computation speed, maybe, for example, if you have secret code from the bank, nowadays still do not worry, because they even use very powerful supercomputer. It takes about 300 years. But for supercomputation, it takes only 30 minutes for that. So it's very different. So nowadays,
Professor
this is
Chao.
already gone. Okay, so that's what I'm going to share with you. Thank you.
All right. Thank you very much. Just about to interrupt your presentations, just on time.
Yes, I know.
Thank you. Very great presentation. So I know it's already past 2 hours of our sessions, but I asked to extend about 15 minutes more, so we still can have the question and answer sessions with the audience and the speakers. Okay, for the next questions, I can see from the chat, we have questions from Nila. Okay, for Ms. Nila, can you unmute yourself and, if possible, turn on the video so you can ask your question directly, and please also mention to whom you ask the question.
Please. No voice.
Not here yet. Okay, I will ask Nila's questions, and I think this questions is more to Arlene and Christine, and after Arlene and Christine answer the question, I think other speakers can also add something. So Nila's question is, hello all, how to maximize students' research project during a pandemic? Okay, I think this question is more precise to address to Arlene and Christine. Do you have any answer for the question?
Okay, so for me, right? Hello.
Arlene and Christine first, and then you can add something, Coming.
Yes.
Okay, so what I would say is trying to find online simulations that don't just like spit out the same exact number every single time is the best way to maximize student research, because a lot of times we see like if we put a simulation on and like we put the ball, you know, and we're having it go at a certain angle, it always comes to the same number, which doesn't involve a lot of opportunities for the students to be able to see the differences that require. So basically, as we're moving on to advanced science, we're needing to do statistics. We're needing to compare that data to really be able to say. So many times I see the younger students go like, oh, this is a significantly different thing. And I'm like, no, significantly has a meaning, okay? That you can't just use that word just like, you know, out of the blue. So as we advance, we really need to be able to focus on doing that analysis of data. That's where it really specializes. That's where we see the kids really be able to expand their research is to pinpoint that information. And so finding simulations or things online that can do that is the best way in this pandemic situation. Other opportunities may be to be able to allow students to have some one-on-one time in laboratory space if the government conditions allow for that, to be able to try and continue research like that.
Okay. Thank you, Christine. Any other speakers want to add something to the question?
As far as physics is concerned, there's a lot of organizations or research centers that offer big data. So the student can acquire this information or acquire this big data that's been researched by other scientists, and they can make their own research out of that. As well, now that everyone has, you know, a smartphone in their hand, they can use, there's a lot of, actually your smartphone has a lot of instrumentations that can let you measure stuff. Speaking of physics, it can measure acceleration. It can measure, of course, just video analysis is one of them. So that's just as far as physics is concerned for me.
Okay, thank you.
So I'm Tommy. Yeah, so maybe I would like to add something. So we've been trying to help students because in Taiwan alone we are quite well to control the academia. But there's one or two schools still hesitate, and at that time, yeah, they prefer to use a kind of simulation, like a physics lab or something. It's good. However, yeah, still the student feel that's not real experimental work for that. So yeah, we try to ask them to do something. Yeah, usually, for example, they can observe. Yeah, for example, which part they can sink into the water. For example, they carry the very heavy 6 kilograms of the water of the tank. They put into the big tank, still they can sink. And also some kind of fruit or some kind of vegetable, some is very heavy like a pineapple. But surprisingly, some of them can also float on the surface of this water for that. So, and then they can design and thinking by themselves. So this way, yeah, it's real. So we can adapt something, right, by simple way. And certainly nowadays, students, most of the students in Taiwan, they have a mobile phone. They can use a video. They can make some kind of recording and they make data, yeah, after the analysis of this. So yeah, this is the kind of approach of learning quite, yeah, come back to the life for that. Yeah, thank you.
Yeah, thank you. I agree. I think this pandemic is a good time to start the collaboration. Okay, now we move to the next question. I saw Mr. Gunawan just raise hand. Do you have any question, Pak Gunawan? Not yet. Okay, so we can move to the next question. You can ask question directly by unmute and address the questions to the speakers, or you can write also in the chat, and we will put you on spotlight. Okay, I want to hear from our audience and teachers who want to ask questions from various countries here. Can you, some of you unmute and ask questions about how to engage with the programs and how to do the collaborations of research with some of the speakers or something? I know some of you have a lot of questions about that kind of things.
Surendra, may I answer some question?
Sure. Yeah.
Even though I think indicated here as private, but I think it's quite useful to other participants. So this is from our friend from Singapore asking about publishing and patent that I have mentioned in my presentation. And I'm glad to know that in Singapore, Dr. Tan's school is doing the same. And he'd like to know who pays for the patent. That's a good question. It's quite expensive, isn't it? And actually, our lucky case, we have PTT, Petroleum Authority of Thailand, as a major sponsor. So PTT support that kind of payment, and that's to answer the question. And also, I have another question about whether the students and teachers are listed in the patent application. Yes, the same as for the published papers. We do the same for the students and teachers. And another question here: how to manage large student population? I think I'm not sure about for me or not, but for us, our student population is not so large. It's 216, and we have 18 students in one class. So for us, it's quite okay to manage students. Thank you for your question.
Okay, thank you. Thank you very much, Tanit. It's very useful. Okay, so since we have a lot of audience here, and with Asian cultures, nobody wants to disturb others. So now I will start by mentioning the countries, and to audience from the countries that I mentioned, you can at least one or two of you can unmute yourself and ask something or discuss something with the speakers. So, okay, the first country I will start with Nepal. Can somebody from Nepal is here? Hello, Nepal.
Hello, yes.
Yeah, okay. I will try to put you on spotlight. You can just ask questions.
Yeah, it is a wonderful program and good discussion. And concerned to the collaborative research work, then how to I would like to ask the question to know about the during the collaboration with science teacher with our research, then what are the factor to mobilize the resources to the student? This question I can put to the Professor Vazili.
Vazili, okay, Professor Vazili.
So could you repeat that question? I just can't sort of, Rajesh, can you repeat that again, please? Sorry.
While we are going to make the collaboration with the international collaboration, then how could we move forward? Is there any circumstances we can to remove and we can make a direct collaboration?
Yes, sure. Yes, yeah. Sure. Because we're very open to that. We had quite a few students coming over from Nepal taking part in our sort of events and summer programs, which was extremely useful for us. And also, we visited last time Nepal as well, and we're very much impressed with the keenness and extremely good, all over the command of English and so on, which is our kids will be very happy to learn from your students, and very much keen to have your students here in Yakutia. And also we can be somehow discuss also possibility of, because we can always provide every possible, the maintenance and everything on us, so there's no problem. You see, only getting here, you see, is the thing. So we very much welcome you to come to Yakutia, especially preferably for you in summer, obviously, which is I would like to say, which is fantastic. And we had a very good people, you see, visiting us from Nepal. For example, the Raj Pant was a very nice and interesting speaker to us last time, a famous neurosurgeon from Nepal who was here in Yakutia. So very, very keen and happy to have your students. So please write to me.
Okay, thank you very much.
Okay.
Yeah.
Okay.
Thank you very much, Dr. Rajesh and Dr. Pavlov. Okay. One more question from Nepal. You already have Dr. Rajesh. Any other question from Nepal before I move?
No, it's okay. Thank you.
Okay, maybe other colleagues from Nepal?
Yeah.
Not yet. Okay, we'll move to next country and then we'll start over again. Next country is India. Somebody from India?
Hello, sir.
Okay. Mute yourself. Okay.
Hello, sir.
Yeah, hello. Yes, please, Dr. Suryavanshi.
Yes, sir. Thank you. Sir, in India, we are very much working on STEAM practices, science research. Hello?
Yes.
Yes, we can hear you, but there is some feedback in your back sound.
Hello, sir.
Yeah, okay, go
Hello?
ahead.
Can you hear me properly?
Yes.
Please.
Hello?
Yeah, we can hear you, Dr. Suryavanshi.
Yes.
Hello, sir. Can you hear me properly?
Yes, we can hear you.
Okay. In India, we are working very much on science research, that we are encouraging the students to participate in science projects. We are working on their innovative ideas. We are encouraging them. I want to know that in foreign countries, in your country, what you are doing special for the encouraging the students, what you are taking special efforts for encouraging the students. Anyone can answer me.
Yeah, do you have any name
I
specific?
cannot hear you, sir.
Do you have any specific speakers you want to ask a question? Hello.
I cannot hear you.
Okay, no problem. Okay, so I think yeah. Do you have any specific name of speakers who want to address the question, Dr. Suryavanshi?
The teacher who is working on the same in the school, please answer. I don't know that who is working in the school or college or in university.
All right. Okay. So yeah, I think Dr. Tan Kosian, so can if you can hear me, you can. I think your work is related with the questions, how to encourage the students doing research project and so on.
Okay, let me try my best to answer the question. Just to repeat the question is how to encourage students or more students to do science, perhaps STEM activities in the area of research. Is that correct? So perhaps I'll try to answer this. I think the recognition from an organization is important because with the support from an organization, there would be more like-minded teachers who will want to create programs or activities for the students. So I think number one, we have to go from this kind of big to look at having the leaders to be able to be aware that this is an important focus for the organization. So with that, once we have the support from the organization of the leaders or of the school, I would then be able to say that looking at what is the agenda for the various organizations, like for example, for my organization, we do want all our students to go through research. And that's why we craft out a plan for them, be it a 3-month plan, 6-month plan, 9-month plan, 1-year plan, that each of them, knowing that their interest is in different areas, could be STEM, could be in humanities, could be in literature, we actually support the teachers in engaging external organizations. That's why I started my presentation with the national agenda, because for us, when we look at the bigger picture, we see a lot of collaboration locally with the various research institutes. And that's where all the international conferences agenda helps to build a picture. Then we actually come down to drive the message to the students, because I think a lot of the research-based practices are self-directed learning. And this echoes with a lot of the presentations from our previous speakers, that the students must be the one to understand that the ideas, the proposals must come from them. So my sensing is that in order to get more students or more such activities, it must come from 2 main areas. It must come externally with the support from the organization. It must then come internally from the students themselves, helping the students to see, supporting them in what kind of models, what kind of samples, what kind of research ideas could be used. And I think that would be one way to go about doing it. Right?
Thank you, sir.
Thank you
very much.
Yeah, I hope that answers your questions. It's a good idea.
Definitely. Thank you, sir.
Bring the students' work on project and being recognized by other organizations. That's very good.
Yes.
Okay, can I move to the next country then? It's time for Mexico. Are you still here? It's already late at night there. I hope our friends from Mexico is still here. Not yet. Okay, then we move to Malaysia then. Any friends from Malaysia?
Sanjay here.
Okay, Sanjay.
Yeah, you're doing a great job hosting the talk here. All right. Nothing. There's no question from my side. All right. Only there's a request that we can more collaborate between other countries like from Russia, Pavlov, and then Taiwan. I hoping we can more collaborate on that. All right. That's all from me. No questions.
Yeah, couldn't agree more with you, Sanjay. Yeah, that's the most important thing from this conference, right? To build the network for the teachers and students, especially for the students, build the network for they being someone, being reach the positions in research institutions, or being someone in the governments. Creating network from this years of schools is very important. Okay, thank you, Sanjay. Now, next country, Indonesia. Do we have somebody from Indonesia? You can unmute yourself and ask the questions. I see many teachers from Indonesia here. Okay, I think I will, if nobody unmute the microphone from Indonesia, I will address Pak Kuncoro. Are you here?
Budiah mungkin.
Pak Kuncoro is not here. Ibu Ros. Not here. Okay, Ibu Dia, are you here?
Yes, I'm here.
I will. Can you turn on the video, Ibu Dia? I will put you on spotlight.
Okay.
All right.
Hello, everyone, and good day. I hope everyone here is in a very good condition. Hello, Mrs. Surya from India. Nice to meet you with all of the teachers and very, very amazing and excellent teachers, mentors from so many countries for the APCYS 2020. And since Pak Sailendra like suddenly asked me to speak something, not really have any preparation, but I think I have two things that I'm so curious I want to share here with all of the mentors. First, I already chat on the chat box. I think this first point is for teachers or mentors from the Kamnutvidya. I heard about this school like from a few years ago, and if I'm not mistaken, first time I heard and I know about the Kamnutvidya school is when I attended and joined an astronomical camp. If I'm not mistaken, it's held by NARIT, National Astronomical Research Institute of Thailand, if I'm not mistaken, in Chiang Mai in the early of 2018. That's the first time I met with few teachers and students from the Kamnutvidya. And it's so interesting event. And then I heard that this school, I mean your school, the Kamnutvidya school, is a kind of gifted school. Something that makes me curious is what the meaning of the word gifted. It's like, is there any special requirements? Is there any special gift or talents that must be shown from candidate to be accepted into your school? Because it's so interesting knowing about gifted schools. That's the first question. And I know that your school is so excellent. One of my students joining the APCYS 2018 or 19, 18, I guess, held by your school in Thailand. And my second question is, I don't know why, but few of my students recently, they are so interesting with the field of astronomical. But I don't know, either any teacher or mentors here that has experience to explore or to develop the curiosity of the students when they want to make a research about astronomy.
Yeah, I know some of them, Ibu Dia.
Yeah, but Mr. Sailendra, like our school, it's conducted by Mr. Sailendra. I think that's because of the collaboration between our school, the CIL, mentoring by Mr. Sailendra, and also the Quest Institute. They launched research to the ISS, but after that, the junior from that previous team, the previous team is already gone. They all are graduated from our school, but after that, they're junior in our school. Like they interesting, maybe not kind of research, but more to exploring. But having a telescope or having the equipment for exploring astronomy, it's not easy. So perhaps anyone has an experience to conduct research project or assignments project about astronomy. Thank you.
Thank you, Dr. Dia. Dr. Dia is a medical doctor and also teaching in high school. So I know related to astronomy, I know Anucha and also Professor Fujoming have experience conducting this research about astronomy with the secondary school. Can Professor Fujoming, can you say something with the research related to astronomy with the secondary school?
Okay, so I'm not expertise on this astronomy, but I certainly do some kind of colleague who is in this area, and we also have students for working in this area. So for astronomy, it's also very interesting. It's cover very broad area, so they can have theoretical approach, and also they can have experimental approach. And for experimental approach, they can have huge, so-called huge macroscopic study, or even for microscope study. Even you probably know the God particle neutrino, like Pearson Chen in our university. They put some kind of special detector in the South Pole. As I know, there's two groups. One, the other group is in Moscow, but they put something in Parallax to make detection of this kind of particle. And certainly, there's also area a student can make a detector, not just the collect data, and also certainly some student they collect data, they try to make a modeling for that. And for real astronomy, certainly there's still a very hot area, like they try to use international observatory. They collect data, for example, to study what's the beginning, of the world, Big Bang for that, for this. So that's also very possible. So if your student is interested in this, maybe you can send me email. I can try to introduce suitable professor for you, to make this kind of remote mentoring for that. Okay.
Okay, thank you so much, Professor.
That's the second question. Is Anucha here? Because Anucha also involved with the International Astronomy Olympiad. So something I can add for Professor Fujoming's answer is that I saw some of the radio telescope in secondary school in Taiwan when I visited Taiwan with Professor Fujoming, and it opened the possibility for collaborations, because at least we need collaborations between telescope or schools in northern hemisphere. So the other telescope in southern hemisphere. That combination or collaboration can create something.
Nice.
Okay. So for the first questions, I think it addressed to Dr. Tanit or Dr. Rachain, Davis, with the gifted students.
Would Dr. Rachain like to answer the question, or you like me to answer the question?
Yes, I gonna start first, and Dr.
Please,
Tanit,
please.
you
Please
can add up later. Okay. When we talk about gifted students, what we're doing here, our school recruiting the student throughout the country. What we call we are the national school, one of the national school, not local school. We have 11 exam center throughout the country. Every year around 5,000 applicants. 5,000. We can accept only 72.
Wow.
72. We have two rounds of examination. The first one is a paper examination. The second one is a practical examination. We give them some kind of equipment, simple equipment, and we give them half a day to solve the problem, like a pizza, like a practical examination. Along with that, they have to submit the portfolio, their experience in the past 2 or 3 years at the school, and we look at their portfolio, what they've been doing, what they working on, the kind of thing, experiment, if they won any prizes, awarded, something like that. That's what we call gifted student. Also, when they come for the first year, we ask them to sit the IQ examination, also EQ examination.
IQ and EQ.
IQ, EQ, and we follow them year after year for 3 years. That's what we're doing here.
But excuse me, that's it means that gifted in a science research, right?
Oh, that's right. I forgot. Gifted in science and mathematics. only.
Yeah, so that's
right,
the track. That's the characteristic of the Kamlutpedia score, right? So not as a gifted like said like a kid's gifted in performing arts, but no, that's not
no.
okay,
Right,
thank you.
That's
Thank you.
That's right.
Thank you. Dr. Tanit, do you want to add something?
Yes, I summarized that in the chat already. I hope everybody can see that. And yeah, I summarized what Dr. Rashin just mentioned. He covered very well, so I don't have to add anything else. But I have one word to say before you close the session. Maybe 1 minute, please.
Yeah. Okay. I will address.
Thank you.
Okay. Thank you, Dr. Dia. So I'm not sure, but if there's any teachers or audience from Singapore or Russia, if you have any questions. I see this speakers from Singapore, Russia, but if there are any audience?
Oh, yes. Would there be all these good presentation that actually receive awards, etc.? Will it be anywhere, put on your site or something, for us to study, for kids? Because they will be asking, you see, they want to see any of the good presentations and so on, or they have to search for the YouTube, presentations or something.
Yeah, I think Center for Young Scientists will upload these sessions on YouTube, and I think you can ask the link to Monica or the committee. Okay, before I close the sessions, any other questions from Guam or Thailand?
Yes, can I say something, please?
Yes, Dr. Tanit.
I like to say that this is excellent session. The name Asia Pacific Conference of Young Scientists, and you organize this session before the real student presentation, allowing teachers to come together and share what happened in certain aspects in their countries. And I could see that we have done several things in common, which is great. It means that we want to create a better world by educating our children. Surendra, as you mentioned, I participated for the first one, have a meeting in Bali with Monica and your friends, and I learned about Surya Institute. I have been very much impressed with what you are doing in Indonesia. I met a few friends who involved with Olympiad in different aspects in physics and so on. I met your friends also. I mentioned to Monica in America, who has been doing very good things for Indonesia. I think this is great. It's for the world, actually. We learn together, we share, and this is a community of learning. And I really like it. And you have share and you have a stimulate question very well. I think this is going to happen more. That's why I think this is a positive thing about COVID-19. Now it allows us to use this platform and communicate each other and learn from each other, understanding one another. I just want to say that I really like it, and thank you everybody. Thank you all for inviting KWIS to get involved. Thank you very much.
Thank you, Dr. Tanit, and I think we all here will agree with you on this. Okay, so it's almost 3 hours. Since we start these sessions, and before we end the sessions, we will have a group photo together. So can I ask all the participants to turn on the video, and we will do the photo session together. Yes, I can see some of them already turned on the video. All right. Oh, I see Anucha is back. We have the previous question was about the astronomy and related to like astronomy Olympiad or something, how to engage those programs with the schools. Maybe we can continue this later after we close the sessions and have a photo session together. I think I can ask the committee to keep the rooms open so you can have to continue the discussion or something. Okay, I can see some of the participants already turned on the video. So I will start to, Arifin from the committee also will start to take the pictures. We only have 2 slides here. Okay, I will start taking pictures. Okay, first one, everybody smile. Okay, I will move to the second one. Right, smile. Right, I can see Tan Kuoshan's there showing his first APCYS t-shirt, the red one. It's very nice. All right, so before I close these sessions, on behalf of the speakers and also the audience, I want to thank the Center for Young Scientists and also Universitas Katolik Parahyangan to make these sessions possible. Thank you to Ibu Monica and Ibu Henny. So before we close these sessions, I think from representative from Universitas Katolik Parahyangan or Center for Young Scientists would like to have some words to our speakers and maybe some to our audience. Ibu Monica or Ibu Henny, please.
I think Bu Henny can say something, please, Bu Henny. Yes.
Ibu Henny, are you still with us? I think she's not here, Bu Monica. So I think you can say something on behalf of Universitas Katolik Parahyangan and CYS.
Okay. Well, thank you very much again to everyone, especially for the speaker, for sharing very valuable information and knowledge for us, for every one of us. And also thank you very much for all participants, all teacher, team leader who is joining this program. Hopefully you can have some fruitful information from here. So again, thank you so much for everyone, and also to Shailendra for being a great host for this event, for this program, and also to Arifin, who is always working with us at the backstage. I think everyone is on the front stage now, yeah. Okay, thank you so much. I give this back to Shailendra.
Okay, thank you, Monica. So before I close the sessions, once again, I want to thank you to all our speakers, to Dr. Tan Kuoshan's very great presentations, and also Dr. Vazili, and all the speakers here, Arlene and Christine, and also Anucha, and Dr. Suryawanshi, Dr. Tanit, and Professor Fujoming. Thank you very much for being a great speakers in these sessions, and thank you for making these sessions possible and a success. And I'd like to introduce someone before I close these sessions. Arifin, can you turn on the video? Where is Arifin? Here you go. Okay. Here, I'd like to introduce Okay. All right. Give a round of applause to Arifin, also Center for Young Scientists, and also Universitas Katolik Parahyangan to make these sessions possible. Thank you very much. And thank you very much also to all the speakers. You've been a very great speakers, and also audience for these last 3 hours. You've been a very great audience, and also very fruitful question and answers. So Thank you all, and I have to close these sessions now, and we will see you again in the next sessions in APCYS. Thank you. Good day.
Okay,
Thank you very
Hello,
much.
thank you. Thank you.
Hello, thank you. Thank you.
Thank you. Thank
สวัสดี
you.
ครับอาจารย์ธนิตสวัสดี
See
ค
you
รับ
guys next year.
Yeah.
Goodbye.
Bye.
Thank you.
Thank you สวัสดีอนุชาแล้วพบกัน
Thank
ครับ
you.
Thank you
ครับ
Bye.
จะพบ
Thank
กันครับ
you.
Bye 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 bye. Bye bye.
Thank you everybody
Bye bye.
great
Bye. Thank you.
Thank you, Christine.
Bye.